Bismillahirrahmanirrahim. Assalamu alaikum. This is the second part of lecture number 4. In first part of lecture number 4, the previous video, we solved question number 1 to question number 5 of exercise 1.1. Exercise 1.1 is from the textbook of Mardan Board first year pre-engineering group. We already discussed that point, that please do not just remember the formula or method for solving the exercise question. Although you can take good grades by just remembering the formula or method to solve the exercise question, because the board exams just include the exercise questions. But when you give exams for different universities admissions, then you will suffer if you just remember the formula or method. If you didn't know the theoretical work of the topic, it will become so difficult for you to understand the upcoming new topics in mathematics. So please do not just remember the formula or method for solving exercise question. Please do the proper theoretical work for each and every question. Now we know that we discussed in detail the theoretical work for the complex number which is used in exercise 1.1. We discussed the background which is necessary for every new topic, because mathematics is cumulative. If you need the previous knowledge of the topic, then you can build a good concept on that topic. So that's why I gave the background of the topic in the first video. Then we discussed a brief history, and that in that brief history we discussed that why we need the study of set of complex numbers. Then we properly defined the set of complex number. Then we discussed the real and imaginary parts, then geometrical representation of a complex number, notation for a set of complex number. Remember that each and every mathematical terminology must have its own definition, its own representation. Its representation mean notation, and its own geometrical interpretation. So you see that we discussed the definition, then the notation for the set of complex number, then its geometrical meaning. You know that the geometrical meaning of set of complex number is a two-dimensional plane, and the geometrical meaning of a complex number is actually a point in a plane. Then we discussed the conjugate of a complex number, absolute of a complex number, which is also known as modulus, or magnitude of a complex number. Then different operation on a complex number, that how we can add two complex number, how we subtract one complex number from another complex number, how we can multiply two complex number, and how we can divide two complex number. Now in this video lecture, in question number 6, we will solve the division of two complex numbers. So for division, we already discussed in theory that we use the process of rationalization. So I briefly revised that process of rationalization from the theory, and then we will switch to question number 6 of exercise 1.1. You see that this is the exercise question. This is question number 6 of exercise 1.1. Perform the indicated division and write the answer in the form of a plus b iota. It means that when you divide two complex number, you will get a single complex number. So now you see that this is the division of a two complex number. How we can divide these two complex number? This is also a division of a two complex number. We know that every number is a complex number. 1 is a complex number because 1 can be written as 1 is equal to 1 plus 0 iota. So according to definition, this is a complex number, but this is a pure real number. So in case of the pure real number, imaginary part of those complex numbers are 0. So this is also a complex number, division of two complex number. This is also a division of two complex number, and this is also a division of two complex number. In denominator we have iota, and iota is also a complex number. Iota is actually named as pure imaginary number. This iota is a pure imaginary number because that iota can be written as 0 plus iota. So this is a complex number in which the real part is 0. So those complex numbers in which the real parts are 0 are called pure imaginary numbers. This is a complex number, but the special name to this complex, those type of complex number, is pure imaginary number. So this is also a division of a two complex number. So how we can divide two complex number? You do not need just practice on these four questions. You need to know the theory. You need to know the basic idea of the division of a two complex number, which is the process of rationalization. So if you know the process of rationalization, then it becomes so easy to perform the division of any two numbers, either it from the book, or either there are two complex numbers for which you are finding the division, and those questions are not included in the book. If you know the process of rationalization, then it is not necessary that you can just solve the exercise question. You can solve any type of question which contain the division of two complex number. So that's why to discuss the question, before to solve the question number 6, we will discuss briefly the division of a complex number. Now you see that I am considering two complex number. Z1 divided by Z2 is equal to A plus B iota divided by C plus D iota. It means that Z1 is a complex number which is A plus B iota. Real part is A, imaginary part is B. The second complex number is Z2, which is C plus D iota. The real part is C, the imaginary part is D. Must remember that in the denominator you see that there is Z2. So please impose this condition on Z2, that Z2 will be never 0. You know that 0 is also a complex number. So whenever you write something in a denominator, so please impose the condition on the denominator that denominator will be always non-zero, because we know that in a mathematics division by 0 is not possible. You get an undefined number which is named as infinity when you divide any expression or any number by 0, which is explained in one of the video, that why division by 0 is not possible and why we are getting infinity or an undefined number when you divide any expression or any number by 0. So I already upload that video for you people. So now you see that this is the division of two complex number. This quotient form contain two complex numbers which you are dividing. You are dividing A plus B iota by C plus D iota. So this is also known as a quotient form. This quotient form in numerator contain a complex number, in denominator contain a complex number. But when you see to the denominator of this quotient, there is a complex number C plus D iota. Now this C plus D iota actually contain two constants which are C and D, real numbers. You know that now in this case Z2 is equal to C plus D iota. So this is a complex number. You know that in a complex number this C belongs to set of real number, this D belongs to set of real numbers. So these two are constants from the set of real numbers. Now these two constants depends on nothing. So these two constants are independent constants. So in denominator you see that there are two independent constants. There are two independent constants, and you know when you are dividing something by a number, it must be a single number. For example, if I divide 4 by 3 plus 1, so we can't divide 4 by 3 and then 4 by 1. We will first add these two numbers to convert this denominator into a single number. So this is the idea. In this case we need to convert this denominator C plus D iota into something which is a single real number, because this denominator contains two independent constants. So that's why for removing these two independent constants we need to take the conjugate of the denominator, and that conjugate will be multiplied and divided with this quotient form. This is the whole. Z1 divided by Z2 mean A plus B iota divided by C plus D iota is your quotient form. So that process is called process of rationalization. So in denominator you see that you get a plus b and into a minus b, which become a square minus b square. So you clearly see that this c square plus d square is actually a real number. So now your denominator is actually a single real number. So now then the division is possible. So that's how we can perform the division of a two complex number, and the process is called rationalization. Now what is rationalization? You see to this writing, the denominator is containing two independent constants c and d, which I already explained, of the fraction z1 divided by 2 to get another complex number from the division of z1 and z2. When you divide two real numbers, you will get again a real number. For example, 4 by 3, let's say 4 by 2, so you will get 2. So the division of two real number, you will get again a real number. So similarly, when you divide two complex number, you will get a single complex number. As you see in the previous video, that when you are adding two complex number, you will get a single complex number. When you subtract a complex number from another, you get a single complex number. When you multiply two complex number, you will get again a single complex number. So you see that the set of complex numbers are closed with respect to multiplication and with respect to addition. It is also closed with respect to division and subtraction. Division is same as multiplication and subtraction is same as division. So from these we can say that closure property is held in the set of complex number with respect to addition and as well as with respect to multiplication. Multiplication also includes division, and addition also includes subtraction. So you see that to get another complex number from dividing z1 and z2, we need to convert the two independent constant into a single real number, which I already explained here. You need to convert this c and d into a single complex, into a single real number, because in this case you see that c, d both are real, but d contain iota as a factor. So this whole is not a real number. This is a complex number. This is a complex number in which both the real and imaginary parts are non-zero. So you clearly see that this thing cannot be converted into a single real number. So we do a process to convert this thing into a single real number, because this contains two independent constants, and this and that real number will contain a single digit. So you can divide that by then the division is possible. This will be done only by multiplying and dividing the conjugate of the denominator with this. The process is called rationalization. So whenever you need to convert, you need to perform the division of a two complex number, you must need the process of rationalization. So what is the process of rationalization? You will see to the denominator of that quotient form. Now question number 6, part number 1, 4 plus iota divided by 3 plus 5 iota. So this is the division of two complex number. Now you see that in this complex number, in this quotient form, this is the quotient form. This is known as quotient form. And this quotient form means you are dividing this complex number by this. So this is the division of a two complex number. So now you will see to the denominator. The denominator contains the complex number 5 plus iota. So you will take the conjugate of this complex number. So from the definition of the conjugate, you know that when you are taking the conjugate of a complex number, conjugate is nothing but just change the sign of the imaginary part. So here the imaginary part is 5 and the sign of the imaginary part is plus. So its conjugate of this complex number is 3 minus 5 iota. So you get the conjugate. So what you can do, you need to multiply and divide this conjugate with this quotient form. This process is called rationalization, and by the help of multiplying and dividing this conjugate to this quotient form, you will get a single real number in the denominator. You will see that here. This process is called, you are removing this 3 and 5 into a single real number. In this case you cannot add 3 with 5 because this 5 contain iota as a factor. So this is a single complex number. But the division of any number by a complex number mean when a complex number in the denominator, you cannot perform the division because this contain two independent constant in the denominator. So you must remove you must convert the two independent constant into a single real number. So the process is called rationalization. So you see that I multiply the conjugate and divide the conjugate with this quotient form. So numerator will be multiplied with numerator, denominator will be multiplied with denominator. So now consider this is a plus b, a minus b. Here a is 3 and b is 5 iota. So a plus b multiplied by a minus b is actually equal to a square minus b square. So this will become 3 square minus 5 iota whole square. Now multiply these two complex number. Horizontal multiplication, 4 multiplied with 3 minus 5 iota plus iota multiplied with 3 minus 5 iota. Now this will become 9 minus 25 iota square, and you know that iota square is equal to minus 1. Now 4 multiplied by 3, 12. 4 multiplied by minus 5, minus 20 iota, plus iota multiplied by 3, 3 iota, plus multiplied by minus, minus iota multiplied by iota, iota square, and 5. So in denominator 9 minus 25 iota square is minus 1. So this is 12 plus 5, because this iota square is minus 1, so minus 1 multiplied by minus, you will get plus 5. So this is equal to 17. This is equal to 17, and then minus 20 iota plus 3 iota is minus 17 iota, and 9 minus multiplied by minus plus, so 9 plus 25 is equal to 35. So now you clearly see that your denominator, which contain two independent constant, by the process of rationalization converted into a single real number. This process is called rationalization. Now you can write this in 17 divided by 34 minus 17 divided by 34 iota. So this is the value of a and this is the value of b. So this is the form of a plus b iota. So you clearly see that you are dividing two complex number, and at the end you will get a single complex number, and this is in the form of a plus b. Here the real part is 17 by 34 and the imaginary part is minus 17 by 34. So 17 by 34 is actually equal to 1 by 2, and 17 by 34 is equal to 1 by 2. So the real part is 1 by 2 and the imaginary part is minus 1 by 2. So you see that when you divide two complex number, you will get again a single complex number. So we can say that closure property is satisfied or hold in the set of complex number as well. So this is the whole idea about dividing two complex number. Now you see that this is also a division of a two complex number. So that in denominator the complex number is minus 8 plus iota. Take the conjugate of this and multiply that conjugate with this quotient form, and also divide that conjugate with this quotient form. So the conjugate will be minus 8 minus iota. Just change the sign of imaginary. Here the imaginary part is 1 because there is nothing with iota. So if there is nothing in iota, we can write 1 multiplied by iota. So the imaginary part is plus 1, so that will become minus 1. So this minus iota. So you can multiply and divide this conjugate of the denominator with this quotient form. So now 1 will multiplied with this minus 8 minus iota. 1 is a multiplicative identity, so it will not change this. So you will get again minus 8 minus iota, and now this is a plus b, a minus b, so a square minus b square. So minus 8 minus iota, this is 64. Now this minus will become plus because the power is even, and this is iota square is equal to minus 1. So 64 minus minus plus 65. So you see that your denominator is converted into a single real number. In that case, you see that the denominator contain two independent constant, minus 8 and plus 1, but you cannot add this minus 8 with the plus 1 because the plus 1 contain iota as a factor. So this is a single complex number. And now so this is this can be written as minus 8 divided by 65 plus minus 1 divided by 65 iota. So this is this can be compared with a plus b iota. So a is minus 8 by 65 and b is minus 1 divided by 65. So the real part is this, and this is the imaginary part. So you see that the division of a two complex number is converted into a single complex number. This one is also a complex number. You know that from the theory that every number is a complex number. One is a complex number because one can be written as 1 plus 0 iota. Every number is a complex number. Every number is complex number. Remember that. Now this is also division of two complex number. Just take the conjugate of this complex number and divide that conjugate and multiply that conjugate with this quotient form, and do the procedure. You will get again. Now this is also the division of a two complex number. Now in denominator you say that you have iota. Iota can be written as 0 plus iota. So this is your complex number. So now the conjugate of this complex number, now here is 1. So this is your imaginary part. So change the sign of the imaginary part. So this will become 0 minus iota, which is written as minus iota. So this is the conjugate of the denominator. Multiply and divide that conjugate with the quotient, with this quotient, and do the process. You see that in denominator you will get plus 1. You clearly see that. So this is the real part and this is the imaginary part. You see it. So this is the division of two complex number. Now question number 7. In question number 7 we will find the absolute of a complex number. We will use the absolute for the set of a complex number. So you know that absolute of a complex number z, of a complex number z, if a complex number is z is equal to a plus b iota, a b belongs from the set of real number and iota is an imaginary unit having value under the root minus 1. So then the absolute or the magnitude or the modulus of a complex number is denoted by z bar, which is equal to a square plus b square square root, positive principal square root of the a square plus b square. A is your real part of the complex number, b is the imaginary part of a complex number. So there are two complex numbers. Z1 is 1 plus 2 iota, Z2 is 2 plus 3 iota. Evaluate Z1 plus Z2 whole absolute. So first of all we will add Z1 and Z2. So add Z1 and Z2. So real part will be added with real part, imaginary part will be added with imaginary part, and there must be iota as a factor written with this the addition of the imaginary part. So from this you will get 3 and from this you will get 5. So 3 plus 5 iota is the addition of these two complex numbers. Now take the absolute on the both sides. So z1 plus z2 is equal to 3 plus 5 iota, taking absolute on both sides. So the absolute z1 plus z2 is equal to absolute 3 plus 5 iota. So now this absolute, this is actually a and this is actually b. So from the definition we know that the absolute is a square plus b square, positive principal square root of a square plus b square. So according to that this will be equal to 3 square plus 5 square square root. So this is 9 plus 25, which is equal to 634. So you must write unit with this because this absolute represent a distance. So this is principal square root of 34. There must be a positive sign, and that must not be negative because it represents a distance. Similarly, you need to find out z1 multiplied by z2 absolute. So first of all you will multiply z1 and z2. You know the multiplication from question number 5, and then you will take the absolute according to the formula. And the division of a two you know the division of a two complex number. First of all you will find the division by using the process of rationalization, and then you will take the absolute by using the formula. Now the division of two complex number gives you the complex number 8 plus 13 iota plus 1 divided by 13 iota. So now the value of a is 8 by 13, the value of b is 1 by 13. So according to the formula, absolute is equal to a square plus b square, principal square root of a square plus b square. So this is a square plus b square square root. Just simplify, you will get the answer. Absolute will be always a positive number, remember that. Now question number 8 of exercise 1.1. Express the following in the standard form of a plus b iota. So in that case, first of all you need to take the LCM, and then simplify. You see that I am taking the LCM. This is the simple LCM that you studied in the previous classes. Now multiply these two complex number. There is addition. Multiply these two complex number and also multiply these two complex number. So from the simplification you get this. From simplification you will get this. So actually this is the division of a two complex number. So now when you are dividing two complex number, you will do the process of rationalization, because the denominator contain two independent constants. So you will take the conjugate of the denominator and multiply that conjugate and divide that conjugate with this quotient form, and multiply numerator with numerator, denominator with denominator. You see that the denominator is converted into a single real number. So this is the whole procedure. This is your real part and this is your imaginary part. So you see that this given expression of real complex numbers, this is a expression, because the first part of this expression contains the division of two complex number. The second term of this is the first term, this is the second term. So the first term contains the division of two complex number, the second term contains the division of two complex number. So you see that this is a expression of a complex number. So when you perform different operations and simplify from this expression, you get a single complex number, in which the real part is this and this is the imaginary part. So in that question you see that we are using the LCM, then we are taking performing the horizontal multiplication, which already you know. Then you are using the fact that iota square is equal to -1. Then you are using the process of rationalization, mean when you are performing the division, you must multiply and divide the conjugate of the denominator with that quotient, and then you, after simplifying, you get the real and imaginary part, and you get the complex number in the form of a plus b iota. Now question number 9, part number 2 is also similar. You can convert this into the now you see that this is 2 plus under the root 9 iota, because you can write this 9 minus 1, and now this can be written as under the root 9 multiplied by under the root 1. Remember that under the root a multiplied by under the root a is equal to under the root ab if a or b one of them is positive, if one of them is positive. For that I explain one thing. Now you see that for that question, please remember this. For any I'm explaining this point. Please see to this point. Square root of a multiplied by square root of a can be written as the square root of ab, mean you can multiply a with b and take a single square root. So now see to this. For any two real number a and b, square root of a multiplied by square root of b is equal to square root of ab is true only when at least one of a and b is either 0 or positive. At least one of a and b is 0 or either positive. If a and b are positive real numbers, then minus a will be negative, minus b will be negative. So you cannot use this result, because this minus a square root and this is minus b square root, so you cannot use that. You will take the single square root and multiply minus a with minus b, so you will get minus multiplied by minus plus and a multiplied by b and square root. This is not true, because you know that square root of minus a is actually equal to square root of a multiplied by iota, because the square root of minus a can be written as a multiplied by -1. So then this is a square root minus 1 square root, so this is a square root iota. So now this thing is not equal to this. This is a wrong result, because minus a square root is equal to square root of a iota, and minus b square root is actually equal to b square root of b iota. So when you are multiplying this is minus a square root multiplied by minus b square root, so this is actually equal to ab iota square, so which is equal to minus square root of ab. So this is equal to minus square root of ab. This is the correct result. So please you see to this example. So remember this. This is just explanation for that point. In mathematics, you clearly know each and every point, otherwise you will get confused in solving question. So these points comes from the theory. You must study the theoretical work of the topic. just solving the exercise question is nothing, but just you are wasting your time. You will get number in a board, but it will be so difficult for you to study the advanced topics in mathematics using that concept which you study in the previous classes. So please do the theoretical work, focus more on the theoretical work. When you know the theoretical work, you will just need to practice that on solving question. Actually, you see that in the that we are discussing the question and the theoretical work is revised so many times. The theoretical work is revising. So this is the aim of the exercise, that you are doing a question while the concept is already known to you. So please focus on the theoretical work. So this is equal to actually this thing is actually equal to, when you multiply this quotient form, you will get this thing. So this is the division of two complex number, and you know the division of two complex number have performed by the process of rationalization. Do yourself. Now this is a plus b whole 1 plus iota whole square. So you will use a plus b whole square formula, which is equal to a square plus b square plus 2ab, and then perform the division by the process of rationalization. You already know this. So these are the assignments for you people. Now you are taking the conjugate of this complex number. This is a question number 9. So first of all, by taking the conjugate of this thing, you need to simplify this. Multiply the numerator, these two numerator with numerator, and multiply these two complex number in numerator, these two complex number in the denominator. So after the simplification, you must get a single complex number. Now after the multiplication, now you see that you get this complex number when you multiply this complex number, this complex number with this, and this complex number with this. So you will get this. So actually this is the division of a two complex number. So you will take the conjugate of this denominator and multiply that conjugate and divide that conjugate with this quotient form. So this is the process of rationalization. So at the end you will get this complex number. So when you simplify this expression, you get this complex number. Now take the conjugate of this complex number. So the conjugate of this thing is actually the conjugate of this bar denotes the conjugate, and you know that conjugate change the sign of imaginary part. So in this case, the imaginary part is minus 16 by 25. So this minus will be converted into plus. So this is the conjugate of that complex number. In this conjugate of a complex number, the real part is this and the imaginary part is this. So this is so much easy. You know the conjugate already. This is another question. This is question number 10. Iota power 18 plus 1 divided by iota power 23 whole power 3. So this is iota power 18 plus 1 power 25 mean 1. When you multiply 1 25 times, you will get 1. And this is 1 power iota 1 divided by iota whole power 25. So this 25 as a power will come on 1 as well as a power an iota as well. So 1 power 25 mean 1 power 25 mean you are multiplying 1 25 times, so you will get 1, and this is iota power 25. Now this iota power 18 can be written as 4 multiplied by 4 plus 2 plus, and this iota power 25 can be written as iota power 4 multiplied by 6 plus 1 whole power 3. So you know that 4 iota power 4k plus 2 is equal to minus 1 minus 1. You know this result. And iota power 4k plus 1 is equal to iota. Sorry for that. Now you see that this you know these are from question number 1. We already discussed these equations are, these relations are not given in your book. Please remember this. So this thing is equal to minus 1 according to this result, and this 1 divided by iota whole power 3. So now taking the LCM. So this iota is a LCM. Iota will be multiplied here, iota multiply with here. So here iota will be cancelled with iota, and here you will get minus iota plus 1 divided by iota whole power 3. So this can be 1 minus iota whole cube and iota cube. Iota cube is actually equal to minus iota. Iota cube can be written as iota multiplied by iota square. Iota square is equal to minus 1. So this is minus iota. So this iota cube is actually minus 1. And this is 1 minus iota whole cube mean a minus b whole cube, which is actually equal to a cube minus b cube minus 3ab into a minus b. So by using that relation, you get this. So this is the division of a two complex number. So perform the division by the process of rationalization. The conjugate of a complex number is minus iota, because this is iota. 0 plus iota, I already explained this point, so you will get this. So this is simple. Now question number 11. This is z1 is equal to 2 minus iota, z2 is equal to 2 plus iota. You need to perform z1 multiplied by z2 divided by z1, that is. So first of all, multiply z1 and z2 and then divide by z1. So this is the multiplication, this is division. So now this is a complex number. This is the division of a two complex number. Do the process of rationalization. So then you need to find out the real part of this. So when you perform this, when you simplify this expression, you get this complex number 2 plus iota. So what is the real part in this? The real, this is the representation for the real part, so the real part is 2. Similarly, you need to find out the imaginary part of 1 divided by z1 multiplied by z2. So first of all, you need to find out z1 divided by 1 divided by z1 and z2. So 1, this is the value of z1, this is the value of z2. So you will get 1 by 5. This can be written as 1 by 5 plus 0. So what is the imaginary part? The imaginary part is 0. So this is question number 11, and this is the whole exercise 1.1. At that point, this is the end of exercise 1.1. So inshallah, in the coming video we will start the theoretical work for exercise 1.2. Thank you.